Welcome to our channel.
Illogical to begin with, do scientists develop bushy skin in a dish? Analysts at Indiana University School of Medicine have effectively built up a technique to develop bristly skin from mouse pluripotent foundational microorganisms, a revelation that could prompt new ways to deal with show illness and new treatments for the treatment of skin issue and tumors. This examination, as of late distributed online in the diary Cell Reports, denotes the main show that hair follicles can be developed in societies of immature microorganisms. The investigation was driven by Carl Kohler, Ph.D., an educator of otolaryngology head and neck surgery at a School of Medicine, and a postdoctoral individual in his lab, Jun Lee, Ph.D. The skin is a mind-boggling organ that has been hard to completely reproduce and keep up in culture for look-into purposes, said Dr. Kohler, who clarifies more in a blog entry. Our investigation demonstrates to energize hair advancement from lab-developed mouse skin, which has been especially troublesome for analysts to reproduce in culture. Dr. Kohler and his group's discoveries expand on their past work making a system for developing internal ear cells from foundational microorganisms, in which mouse undifferentiated organisms are refined in a three-dimensional ball and treated with particular flagging atoms to persuade the cells into delivering inward ear tissue. The scientists saw that skin was a result of the internal ear development process. In the creating incipient organism, the inward ear originates from an indistinguishable layer of cells from the best layer of the skin, the epidermis, so it was nothing unexpected that skin and internal ear tissue shaped pair, Dr. Kohler said. We were astonished to find that the base layer of the skin, the dermis, additionally creates. In the present investigation, Dr. Kohler and his group indicate how the epidermis and dermis cells frame a circle-like bunch of cells, called a skin organoid. The phones in skin organoids are sorted out much like cells in ordinary skin, however back to front, which means the best layer of the skin faces the inside of the organoid. The group distinguished culture conditions that permitted skin organoids to continue through the phases of advancement much like skin in the incipient organism. After around 20 days, we were astonished to see that skin organoids grew hair follicles, Dr. Kohler said. The underlying foundations of the follicles descend from the skin organoids every which way. The analysts affirmed that the planning of improvement and articulation of key proteins intently coordinate skin and hair advancement in the mouse developing life. To approve their discoveries, the E-group worked together with Stefan Heller, Ph.D., Edward C. Also, Amy H. Sewell Professor of Otolaryngology Head and Neck Surgery at Stanford University, whose lab individuals affirmed that the procedure was reproducible with immature microorganisms from other mouse strains. Notwithstanding the major epidermal and dermal cell rights, we likewise discovered particular cell composes, for example, melanocytes, pigment cells, Merkel cells, touch-detecting cells, adipocytes, fat cells, sebaceous organ cells, and hair follicle undifferentiated cells in organoids, Dr. Kohler said. This is intriguing in light of the fact that it demonstrates that in the event that we infer the fundamental building pieces of skin together in culture, at that point these different cell composes will self-remass individually. Dr. Lee, first creator on the examination, said these discoveries fill in as an outline for how to make sans preparation the whole skin organ utilizing immature microorganisms. My expectation is that by enhancing skin in a dish models we can extraordinarily decrease the forfeit of exploratory creatures and at last enable patients with skin-related issues to carry on with a superior life, Dr. Lee said. Dr. Kohler said he alerts that there are a few specialized obstacles that they still can't seem to overcome for the skin organoid model to achieve its maximum capacity as a medication disclosure instrument. For example, the skin organoids are missing resistant cells, veins and nerve endings found in ordinary skin. The state of skin organoid is another issue that should be tended to later on, he said. Since the organoids are back to front contrasted with typical skin, the layers of dead cells and hairs can't be shed as they are ordinarily, so we have to figure out how to flip the structure of skin organoids. Without these progressions, the skin organoids have a time span of usability of about a month, which is sufficiently long to consider the entire advancement of mouse skin and hair. Kohler and his group are right now utilizing the mouse organoids as a layout to get bristly skin from human pluripotent immature microorganisms. This work can possibly prompt new skin uniting systems, consolidating hair follicles, and treatments for human maladies, including alopecia, skin inflammation and skin malignancies. Extra scientists on the investigation incorporate Peijiao Tang, Ph.D., of his School of Medicine, and Robert Bosk, M.D., and Byron Hartman, Ph.D., of Stanford University. Dr. Bosk is as of now at the University of Lübeck. Thank you for watching our video. Do not forget to subscribe to see our next video.